All right, alkyl is a pretty big class of compounds. Basically, it's a hydrocarbon that has a halogen hanging off of it. Same thing with the primary, secondary, and tertiary, as we saw with alcohols. If you have, so the carbon that has the halogen on it, if it's attached to one carbon, it's called primary. If it's two carbons, it's secondary, and if it's three carbons, it's a tertiary alcohol. Right? We've learned all that before. These do have a dipole, so technically they are polar. However, they do not form hydrogen bonds. So they are technically a nonpolar solvent, even though it's a polar molecule. I know sometimes people get this confused. It's like, well, it's polar, shouldn't it be soluble in water? Well, what makes something soluble in water is if it can form an intermolecular force with water. If it can form an intermolecular force with water, it has a good chance of being soluble in water. If it does not, then it doesn't. It doesn't matter if you classify it as a polar or nonpolar molecule. All right. So as a result of this, they do have higher melting and boiling points than alkanes, but much lower than alcohols. Kind of probably similar to ethers. Um, I've never really looked, but maybe they'll show an example of that. But I would say they're probably in the same um, uh, class as an ether, as far as like the melting points and boiling points. All right, so what change? So what affects the boiling and melting point? Obviously, it's the size of the alkyl group. The larger the molecule, the higher the boiling point and melting point. Also, the halogen. All right, iodine is a gigantic molecule compared to fluorine. So things with iodine and bromine on it, those usually have much higher melting and boiling points. In fact, iodine itself is actually a solid. Bromine is a liquid. Chlorine and fluorine is a gas. So if you look at the periodic table, and if you go specifically at the halogens, so iodine is down here, then you have bromine right there, and then chlorine, and then fluorine. So fluorine is the smallest, iodine is the biggest. Iodine is a solid. Excuse me, I had a cough there for a second. Bromine is a liquid, and then these two are a gas. Chlorine is kind of a liquid gaseous type of, it's kind of, I think the boiling point is pretty close to like the melting point of water, or at room temperature. All right, alkyl groups, all alkyl groups are insoluble in water. It doesn't matter how many you have. So you can kind of see, so look at this comparison. So here I have a chlorine. I have two carbons with three carbons. Obviously, as I get a bigger alkyl group, my boiling point goes up, 35 degrees. Now, look at the same compounds. I have chloropropane and bromopropane. So I go from a chlorine to a bromine, which is much larger. And, I'm kind of adding almost 30 degrees, about 25 degrees of boiling point. All right, so this kind of is an example of proving this. Larger alkyl groups, higher boiling points and melting points, and larger halogens, higher boiling points and melting points. But they are all completely insoluble in water. It doesn't matter if you have one carbon or 1,000 carbons. Okay? Naming them is no different than naming alkanes. You start on the side closest to the nearest substituent. It doesn't have to be the halogen. All right, if the methyl group was here and the chlorine was here, you would still start counting on the right side. Okay, so let me just get to the answer here. So this is, so in alphabetically, so 2-chloro, 5-methyl, heptane. All right, alphabetize. So 2-chloro. So all of the halogens end in O. Chloro, iodo, iodo. I know it sounds funny, but iodo, fluoro, and bromo. All right. Some interesting alkyl halides. Chloromethane is produced by kelp, believe it or not, and algae, and it comes from the emissions from volcanoes. Dichloromethane is a solvent once used to decaffeinate coffee. The lab we did when we isolated caffeine from tea, what solvent did we use? If you don't remember, I'll give you a hint. It's dichloromethane. So that's organic molecules are very soluble in dichloromethane. It's kind of one of these solvents that pretty much everything is soluble. If it's nonpolar, if it does not dissolve in water, it will dissolve in dichloromethane. Trichloromethane is called chloroform. Some people have heard of that, or carbon tetrachloride is with 4 carbons. These are solvents. They are nasty, nasty compounds. Let's stop right there. That's all we have for alkyl halides, and then we'll come back and talk about